welcome to you all in my Maths and Experience Mathematics. Before starting, I want you to make sure that you subscribe my channel and press bell icon so that when I make new videos, you will be informed and I will also be encouraged. So, without delay, let's start. Today's topics: geometrical interpretation of derivative. This derivative concept was arisen while calculating the velocity of the non-uniform velocity described by a particle or finding out the tangent line to the curve. And this derivative concept every science student need to know to understand physics. So I have chosen this geometrical interpretation of derivative. This will be helpful to mathematics students as well as science students of biology group. Okay, so for this we will take a continuous curve y equals to fx. This is the continuous curve y equals to fx. Let us take 2 points P and Q on this curve. Let P and Q be any 2 points on the curve. So this PQ is the second line joining this point P and Q. This PQ is the second line joining the point P and Q. And when Q moves along the curve and approaches to P, and at that time the second PQ rotates about P, and when Q ultimately coincides with P, at the time second PQ becomes tangent at the point P. So when Q approaches to P and when Q ultimately coincides with P, at the time this second PQ becomes tangent to the point P, and let this angle PN x be theta, and from P and Q let us draw PL and QM perpendicular to x-axis. Also from P, let us draw PR perpendicular to QN, and let the coordinates of the point P and Q be x, y and x dash, y dash respectively. So this OL length, this is x, and this OM length, it is x dash. Similarly, this length is y dash, and this length is y, and now from this y dash, if you subtract y, then this much length equals to y dash minus this much length will be y dash minus y. Okay, so here this y equals to fx, this is continuous curve, and pxy and qx dash y dash are any 2 points on the curve, and when p moves along the curve and reaches to the point q, at the time this p moves horizontally through pr distance and vertically through rq distance, and when we join p and q, this pq is second to the curve. Now here slope of second pq equals to qr over pr. We have supposed that this angle is theta, then this angle qpr is also theta. So slope of the second pq becomes tan theta, that is qr over pr. So qr distance is y dash minus y, and pr distance is x dash minus x, and we denote this y dash minus y by del y, x dash minus x by del x. Okay, we have x dash minus x equals to del x, y dash minus y equals to del y, which are called increment in x and increment in y respectively. Okay, so when this q moves along the curve and approaches to p, at the time the second pq moves around this p, and when q coincides with p, at the time the second pq is tangent at the point p, and this pt is tangent to the curve at the point p. Let us suppose that this makes an angle phi with x-axis. So when q coincides with p, at that time this x increment del x and y increment del y both are 0. When q approaches to p and coincides with p, then del x and del y approaches to 0, both approach to 0. In this limiting condition, this limiting condition of the tangent is the limiting condition of the second is the tangent at the point p, that is limit del x approaches to 0, del y over del x equals to limit del x approaches to 0, del y over del x is tan theta, and this equals to in this limited condition, this will change to tan phi. Okay, this becomes the, in this limited condition, this becomes tangent to the point P on the curve, and here this del y, limit del x approaches to 0, this del y from here is, let us calculate in rough. So from here del y equals to, this del y equals to y dash minus y. So y dash is, our curve is y equal to fx, so y dash will be fx dash minus y is fx, and x dash from here is, our x dash minus x value is del x, so x dash will be x plus del x, so fx dash means it will be fx plus del x minus fx. So del y becomes fx plus del x minus fx. So this del y equals to, we can write fx plus del x minus fx over this del x. Okay, so this equals to tan phi. So here this quantity, this limiting value of del y over del x, when del x approaches to 0, it is known as the derivative of the function y equals to fx. This is the geometrical concept of the derivative. That means derivative gives us the slope of the tangent at any point on the curve. Therefore, it is denoted by dy over dx equals to limit del x approaches to 0, del y over del x equals to limit del x approaches to 0, f x plus del x minus fx over del x equals to, it is tan phi. Okay, it is the slope of the tangent at the point P. So here I haven't written it in much detail because my aim is to give the brief concept of the derivative even to the biology students who need not study mathematics, but they need the concept of the derivative to understand physics. I hope that you like my video. So once again I want to request you to subscribe my channel and press bell icon so that I will be encouraged and you will also get notification in coming days. Thank you for watching. Thank you very much.